Okay, cool. So I'm going to do a couple other examples of representing graphs using matrices. We're going to look at a multigraph and a digraph. So in this first example over here, I'm just going to make my matrix right here. I only have three vertices here, so that's all I need to do. But in this graph, since it's a multigraph, we have multiple edges and also loops. And actually, I just realized this is probably a pseudo-graph. Sorry about that, because I put loops in there. So in this case, what that means is both of those rules from before, both of those things I pointed out from before, that there were only zeros and ones, and that we had only zeros on the main diagonal. Neither of those is going to be true any longer because we have multi-edges and we also have loops. So here, A is not adjacent to itself, but it is adjacent to B twice because there's two edges there, and then it's adjacent to C once. B is adjacent to A twice, but nothing else. C is adjacent to A once, not B, but it's adjacent to itself also once. What you're doing here, what determines these numbers is the number of edges, it's not like a degree where you count the loop as two. You count the loop as a single edge from C to C. So that's why it's a one. If you had two loops, which is certainly reasonable, I mean, you could have more than one loop, then you could have other numbers besides one, like three, two, or three, or four. But we're only going to be using natural numbers here because we're counting the number of edges. So in this case, we can have numbers greater than one. All right. In the digraph example, now that our edges are directed, and we make the matrix, we're not going to have symmetry any longer. Oh, we still have symmetry over here. But this time, A is adjacent to itself because we have an edge from A to A. There we go, one of those. We also have an edge from A to B, and so it's always just like when you're labeling entries. It's always row first, column second. So, and this is exactly like it was for the relation digraphs as well. When we have an edge from A to B, we go row A, column B, and put a 1 there. We don't have an edge from A to C, so in row A, column C, we will put a 0. Now, B, there's no edge back to A again, so we're going to put a 0 in the row B, column A. A 0 here because we have no loop, but we do have an edge from B to C. Put 1 there. And then for C, we have edges to A and B, but not itself. So there we go. So in this example, we have it is no longer symmetrical. You could have non-symmetrical, and you could have like more than one arrow. Like for example, we could do multi edges like this, and make some of these entries numbers greater than one. But that's just that's just showing what it looks like and what kind of matrices you can get for different types of graphs.